Hello everyone. Welcome to this seminar today. Thank you for attending this presentation. So at first, I will introduce the two speakers today. So my colleague Olivier Claire,
Hello.
who is working at SCAIME for 25 years, if I'm correct,
Right.
Olivier.
Yes, you're right.
And he's working in our marketing team as a product manager for test and measurement applications, mainly related to force measurement, torque measurements, displacement measurement, and strain measurement, and load pin being part of our force range of sensors. And myself, I'm Nicolas Joannes, Export Area Manager at SCAIME since 2016, in charge of Eastern Europe and Asia Pacific countries. At first, let me shortly present you the rules of operation during this webinar. As you may have noticed, your microphone is off, but also your camera. But you can at any time ask questions to our presentation team. So today we have Yvan Berthollet, our colleague who is in charge of this presentation, and you can at any time ask questions through the Q&R tool that you can see at the bottom of your screen. So Q&R, question and reply. And if you click on this icon, on this tab, you will access to a window in which you can write your question. Either question related to the presentation by itself, if you have any questions related to the products, to the applications or anything, or question related to the use of the Zoom application for this webinar, and Yvan will answer you. So he will answer you if it's related to the use of the Zoom application, and then he will write down, record your technical questions that we would answer at the end of this presentation, and it will be answered by our expert, Olivier Claire. Let's now start with this presentation. So presentations related to the use of load pins in industrial and lifting applications. So you have already a few pictures describing some applications, but it's not an exhaustive list, of course. First, about the sectors. So load pins are used in different sectors. This is not an exclusive list, but we can mainly list the industry, of course, any kind of lifting applications that we will describe later on, of course, the production of metal and materials, but also in the field of agriculture, naval construction, and railway. The main area of expertise for the use of load pins are the overload detection, which is very common, test on equipment, weighing solutions, because load pins can, even if it's considered as a force sensor, can be used for weighing applications, but also control and monitoring applications. At first, we will shortly describe the principle of load pins and the technology. So how it works, what it is, how it's made. So a load pin is a mechanical axial. So if we can say a bar of metal that is going to be equipped with a measuring system in order to measure a force applied to the beam, through the use of strain gauges that you can see on this drawing. In order to measure a deformation of the beam, we will generate a shear plan, a measuring area, where the force should be applied. And on each side of this measuring area, we will machine 2 grooves to generate a deformation section. Strain gauges will be installed at each end of the shear plan within the center of the pin, as you can see from this drawing. So load pins are designed for many diverse applications, as we saw before from the pictures, as direct replacement of mechanical axial or pivot pins. It makes it easy to implement and do not normally require any change to the structure being monitored, which makes it very easy to implement in your systems. Unusual capacities, range of capacities go from 20 kilo for the smaller ones up to 100 ton. Now about strain gauges. So the technology used in load pins in order to measure the force are strain gauges. So a strain gauge, very shortly, is a device which translates the deformation on a part into a change in electrical resistance. Basically, a strain gauge is a resistance. The most common strain gauge consists of a very thin wire or foil element arranged as a grid, as you can see from the picture. So when a stress or a force is applied to the support on which we will glue the strain gauge, it will result in a change of its electrical resistance being proportional to the stress applied. Just for information, the usual range of resistance for strain gauge go from 350 ohm up to 1000 ohm. So now, how are used strain gauges? So the strain gauges will be used in a Winston bridge circuit that you can see from this drawing. A Winston bridge circuit is a configuration of 4 resistors that will be strain gauges in the case of load pins. And by replacing a resistor on the bridge, we can easily measure the change in the output signal and use it to assess the applied force. So through this screen, you can see different kind of typical installation of load pins. So as we said before, a load pin is basically a mechanical axle that will be installed on a pulley, as an example, as you can see from this drawing, in order to measure the force indicated with the red arrow in this drawing. So now a few words about the mounting of load pins, because this is a very important point to ensure a good accuracy of measurement. So at first, the load pin should be locked in its position, because a load pin is mainly designed to measure the force in only one direction. So we should make sure that the load pin will not rotate in its support, or even will not have a translation movement in the support. So as you can see, you can use a locking system to stop the translation, the axial translation, and we will describe just after the way to avoid the rotation. So about the mounting instructions, as we saw before, a load pin need to require to bend in order to measure the force applied. So it is very, very important that in your system you define spaces in order to let the load pin bend in its support. As you can see from this drawing, there are mainly two spaces, gap that needs to be defined. So the space J, which is on the diameter of the pin, in order for the pin to bend in its position, and but also a gap related to the locking system in the translation, axial translation, so that the stress cannot, any stress or efforts cannot go through the locking system to the load pin. Otherwise, it's gonna affect your measurement. Something very important also in order to ensure a good accuracy of measurement with load pins are the fact to avoid any parasite efforts, forces. So as we said before, a load pin is designed to measure the force in only one direction, as you can see on this drawing from the green arrow. But it is very important to avoid all other efforts that could be applied to the pin, like axial efforts or radial efforts, or even torque effects applied to the pin. Otherwise, it's gonna affect your measurement and therefore reduce the accuracy of measurement. What's very important, what is the force which is measured with a load pin? As we said, the load pin is usually used to replace a mechanical axle on a pulley, as an example. And what the load pin will measure is not the force directly applied to the cable, but is a resulting force applied to the pulley, as you can see from this drawing. So the resultant force measured by the load pin can be different from the load applied to the wire or to the cable. And you can see here a calculation formula to calculate the resulting force applied. This is also very important in order to evaluate potential errors of measurements. So if you have any change in the direction of the force applied, it's going to directly affect the accuracy of measurement. And this error will be directly proportional to the angle made between the resulting force and the angle or the rotation effect. So this is something you should really pay attention to in your systems and make sure that there is no possible movement, displacement of the pin. Now, what is the output signal that you get from a load pin? So as we said before, a load pin is a mechanical axle with embedded strain gauges to measure a force. So its output signal will be proportional to the load or to the force applied to the pin. The nominal output signal is called the sensitivity of the load pin. And this is linked to the capacity of the load pin. The sensitivity for strain gauges, load pins, or even load cells, so any sensors equipped with strain gauges, is expressed in millivolt per volt, given for the signal at nominal capacity, so at full capacity of measurement of the sensor. A load pin is a passive component, so it means that it needs to be power supply to measure a force or a load. This is called the excitation voltage. So this, I will describe it later on, is related also to the electronic you will use to make the measurement. The standard range of excitation voltage for load pins go from 3 volt to 15 volt power supply, depending again on your electronic, measuring electronic. Now, how to calculate the output signal that you can expect from your measuring system. The output signal is directly related between the sensitivity of the load pin and the excitation voltage that you will apply. So calculation is very easy. Output signal equals the sensitivity in millivolt per volt multiplied by the excitation voltage. So we can see two examples. Let's take an example with a load pin having a measuring range, so a nominal load of 1 kilonewton, 1000 Newton, offering a sensitivity of 2 millivolt per volt, which is the sensitivity at maximum load, so corresponding to 1 kilonewton. And with an excitation voltage coming from the electronic you will be using of 10 volt. So the output signal that you will get at full capacity, so when you apply a load or a force of 1 kilonewton, will be the sensitivity, 2 millivolt per volt, multiplied by the excitation voltage, 10 volt. So it will give you an output signal of 20 millivolt when the load pin is loaded at full capacity. Let's now take another example with the same load pin. If you apply a force of 500 Newton, so 500 Newton, which is 50% of your nominal load, the output signal will be 50% of your sensitivity, 2 millivolt per volt, multiplied by the excitation voltage, 10 volt. So it means a result of 10 millivolt. So we see that the output signal is directly proportional to the load that you will apply to the sensor. At full capacity, 1 kilonewton, you get 20 millivolt output signal. At half of the capacity, you get 10 millivolt signal. So a measuring, as we said before, a measuring electronic is therefore needed at first to power supply your sensor, but also to process the output signal of the sensor. So we can now describe a SCAIME range of measuring electronics that can be used with load pins. At first, our CPJ, analog signal conditioner, which is a transmitter, analog transmitter, able to convert the millivolt signal from the load pin into an analog signal, 0-10 volt or 420 milliamp. And then you can connect this electronic to your PLC to process the data. A second range of electronic is our range of E04 digital transmitters, available either in write-in version, as you see here, with the version with the black housing, or a version, a stainless steel box version, in which you can integrate a display, touch panel, in order to see the results. So E04 is a range of digital transmitters that will convert the millivolt signal from the load pin into a digital signal. So it means that these electronics integrate on A to D conversion board. And the signal that you can get with this range of digital transmitters is either a serial communication, RS485 Modbus, CAN open, or even Ethernet communications, Ethernet IP, Profinet, EtherCAT, or even Modbus TCP. Some other electronics are our range of indicators, PAX or IP50 indicators with display, but also smart indicators like our F381 indicator, able to process, able to control your process, your measuring process. Also, our range of interrogator for data acquisition on a PC, our SI USB 3 data acquisition unit that you can connect to a PC through a USB connection, and then use a dedicated software for data analysis. And last range of measuring electronics, a range of handheld display, mainly dedicated for on-site measurement with our IPM25 and GM80. Now, our standard ranges of load pins. So SCAIME offer two ranges of load pins. The M15 range with load pins going from 20 kilo up to 300 kilo, or 0.2 kilonewton to 3 kilonewton. The accuracy that you can expect with these load pins is about 0.5% of the nominal load, but also available with an accuracy at 0.1% in option. Something very important, this range of load pin offer a high safety coefficient over 300% of the nominal load. And the second range, which is our M16 range, dedicated for higher capacities, going from 500 kilo up to 100 ton, so 5 kilonewton to 1000 kilonewton. Accuracy that you can expect is similar with our M15 range, 0.5% or 0.1% in option. And the safety coefficient is over 500% of the nominal load. So the two ranges of load pin I presented before are our standard load pins. But we can also tailor-made load pins, so propose special load pins with special dimensions or special sensitivity on request. And you can see from the pictures on the screen a few examples with either very small ones or very large load pins. Those load pins fully comply. The main advantage is that these load pins will fully comply with your applications and therefore will not require any change in the structure to be monitored. So this is very important because it means that it will be for you very easy to implement, because you will only have to replace an existing axial by the corresponding load pin, but also cost effective for you because there's no modification of the structure to be done. So to do so, if you have any interest in tailor-made load pins, we've designed a form to be filled in which you can indicate the specifications which are required in your process, in your applications. So we can divide this sheet in two parts or two steps. So the step one, as you can see on this screen, is to define, of course, the required dimensions for the pin, but also the measuring range which is needed. You can also define, as you can see, the service load, the maximum load to be measured, either in Newton or in kilogram, but also define the ultimate load. So if you have any risk in your system to have important overloads, then you can define a specific value through this form. The second step will be to define the output signal which is needed. So either a signal in millivolt per volt, as we noticed before, or we also offer the possibility to integrate in our load pins an electronic cards able to convert the millivolt in 420 milliamp or 0.10 volt output signal, so that your load pin could be therefore directly connected to a PLC without using a third electronic. We also offer something very important, mainly dedicated for security reasons, the possibility to make a redundancy of the signal. So the idea of this option is to to design two different bridges inside the same sensor, so that you can have two channel of measurements and two output signals, and compare these two signals. When everything works fine, the two signals will be similar. If there is any difference in the values, then it means that something is defective in your system. So very important option for security aspects. And the last thing to be defined is related to the electrical connection. So if you would prefer a cable output on what is the length of the cable which is required in this case, or a connector output. You can also define a last point, which is the IP protection needed in your applications related to the environment where it will be used. So now let's go to the presentation of some application cases in different sectors. The main idea, of course, this is not an exhaustive list of all possible applications, but the idea is to show you a large range of applications to give you possible applications. So the first part is related to lifting applications, which is a very common application for the use of load pins. You can see from the pictures here, so the crane applications, so lifting applications for cranes, and the main reason of using load pins will be to be able to detect an overload of the crane. In these applications, we have designed a custom-made load pin, so having the same dimension of the mechanical axle, and it was connected to our CPJ analog signal conditioner. A second applications for lifting applications related to logistic warehouse. So in these applications, we have proposed the use of our standard load pin, M16, with E0 4T digital transmitters. And the idea was to build a security system. So in this case, if the transstoker displacement is stopped, then the signal from the E0 4T will be increased suddenly, and a set point will be activated so that the PLC can immediately stop the entire system. Other lifting applications. So the main point for this application was to lift up a table, and the lifting process was made using 8 pulleys. So we have been asked to replace all the axles by load pins, and in these applications we've used dual bridges load pins. So as I said before, with a redundancy of the signal. So each load pin were able to provide 2 signals for security aspects. So in this case, we also integrated an electronic board into the load pin, so that the load pin was able to offer a direct 420 milliamp output signal. The main reason of this system was to ensure that the table was lifted up on a plan level. Synchronized. Thank you, Olivier. Some other possible applications in building and constructions. So we have an example here with the overload control of dam gates, in which we've used again dual bridge load pins, so with the redundancy of the signal, having a capacity of 800 kilonewton. And so each load pin was offering 2 signals, so we've used 2 electronics to monitor this system. Interesting applications with this technical spool. So this spool was equipped with a floor that could be lifted up. And so the articulation of this floor was made by 4 articulation points. So we've used in this application 4 load pins with our IP50 indicators to control continuously, permanently, the articulation of the floor of this spool. Now, industrial applications. So as you can see from this application, this was the monitoring of a molten steel oven, which was equipped with very large load pins, because each load pin was about 150 kilogram, having a length close from 1 meter. So you can see a picture of the load pin, which is here, and the load pins were connected to inert 4 electronics. In this system, using load pin was very interesting because this kind of steel or iron oven are articulated. So in this case, the oven was able to rotate at 90 degrees. So using load pin was very convenient for this kind of articulated application. Another industrial application, this time related to weighing, to weight measurement. So in these systems, we have used 2 load pins on the pulley that you can see at the top of the structure to measure the tension applied to the cable and to get the corresponding weight into the tank. A few applications for naval applications. So of course, load pins are mainly used in shipyards. Also for lifting applications, as you can see from this picture. But we have some other applications like this one, where load pins were used to measure the tension, the force, tension force applied to the ropes to maintain the ship in its position. And a total of 12 load pins were used in these applications to monitor the tension of these ropes and to help the harbor to position correctly the ship in a correct position, if I can say. Another naval application, this one very close from SCAIME, because this system was implemented in the Léman Lake, which is a lake on the border of France and Switzerland. And the main idea of this system was to make an overload detection of the net, because if the net is too much loaded, then it can break. So at the fixing point of the net, as you can see from these pictures, we've replaced the mechanical axial by load pins so that we can continuously monitor the tension applied to the net. Agricultural applications, we have this application in which we've used tailor-made load pins to measure the tension force applied to the ropes used to cycle the straw balls. And these load pins were having a capacity of 10 kilonewton, and was very helpful to ensure that the rope is not broken during the process, but also to ensure a good compaction of the straw ball. Railway, now we reach the last application cases, so railway application. This is an application in which we set a monitoring system for the switcher, the track switcher to monitor this this system. Another railway application, this time related to the this system was implemented into a towing train as a test bench, if I remember correctly. So the idea, the load pins were implemented in the front part of the towing train to be able to measure and to control the force needed to move the train. So in this application, the train was pushing on a static bumper, as we can see from this picture, to control the force, pushing force of the machine. Yes. And maybe one case. So as you can see, this was on a test made on site, of course, and we've used for this application an OnDemand display to record the data. Now, last application on, if I can say, a kind of funny application, which is not very common, as you can notice from the picture, application for a special vehicle. This vehicle was basically working on a similar way as an electrical bicycle. So there was an electrical motor integrated on the vehicle, but also the vehicle was pulled by horses. And the idea was to design an assisting system to the horse. So the force value, so the load pin was able to measure continuously the pulling force generated by the horse. The force value was transmitted in real time from the Node 4 to a PLC embedded, integrated in this vehicle. And function of the force, the electrical motor was generating a proportional assistance to the rear wheels. In addition, we can mention that a gyroscope makes it possible to know the inclination of the ground and therefore assist in a stronger way in the ascent process, but also reload the batteries in descent cases. So quite special application indeed. But as you can see, load pins can be used in a very wide range of applications and sectors. Just to finalize this presentation, I would like to list the main points, just for you to remember the main points of this presentation. So load pins are mainly offer ranges of measurements from 20 kilo up to 100 ton, but of course we can design tailor-made load pins. We have the possibility to offer, for security reasons, a redundancy of the signal, so two different signals in the same sensor. Also something very important, we are on the process to get the ATEX and IECEX certification for use of load pins in hazardous environment. And this will come very soon in the coming months, Q2 or Q3 this year. So within a few months, we will have the possibility to offer you this kind of certifications. Once again, the main sectors and the main area of expertise, main sectors, the industry, of course, any kind of lifting applications, the production of metal and materials, agriculture, naval, railway, and the area of expertise, overload detection, which is a very common application for the use of load pins, test equipment, weighing measurement also, and control and monitoring. So thank you very much for your time, for attending this this presentation today. We can now go to the time for questions. So please do not hesitate to ask any questions you would have related to this kind of product or even to the applications, and we will be able to happy to answer you. Ivan, do we have a few questions asked during the?
Just the one that I gave you.
Okay.
Okay. So Ivan, give me 3 questions that you have sent. One of the question is about the AP rating protection. It's possible to, in standard general is 65, AP 65, but no problem to increase to AP 67 or in some case IP 68. No problem. Just ask to SCAIME and we can check this and give you a quotation. Another question is about accuracy of the load pin. So you have seen on the slide that is possible with the standard load pin to have the standard is 0.5%, but we can increase to 0.1%. The same thing is available for custom-made load pin. If you need more than 0.5%, you can ask, write it, and no problem, we can check and give you if it's possible or not, but in 90% of the case, it's possible. Another question is, okay, with the standard load pin of our catalog, 3M15 or M16, the standard length of cable is 5 meters. But if you need more, 10 meters cable or more, it's not a problem. Just ask the question to the salesman of SCAIME, and no problem, we can give you a quotation, we can make this, it's not a problem. It's a 3 questions I received. Evan, there is another question?
Any new questions now,
no
Ivan?
No question for the moment.
No other questions. So it's time to finish. You think?
Yeah. So thank you very much again for attending this this presentation today. We hope it's been very interesting for you, and at least that it gave you a better vision overview of what are the different possible applications for load pins. That's indeed a kind of sensor that we can find in many different kind of applications. Anytime you have to measure a tension force applied to a rotating system like a pulley. So thank you again. And please do not hesitate to contact us if you have any further questions about it. Thank you.
Thank you. Have a nice day. Bye-bye.
Bye-bye.